Today I want to demo the other platform. It is ESP8266. There's a number of these that you can buy on eBay. This one costs less than $3, but it probably take a month. So as I said, if you're interested in putting Wi-Fi into your 445L project, go ahead and get one of these on order. If you already have it in time, you can do lab 4 on it. If you don't have it, obviously you have to do lab 4 on the CC3100. Now there's a lot of stuff out there on this device. What you want to get is the starter project. For that was dated this weekend, whatever Saturday was, on the 18th. This is the circuit diagram. It's remarkable in a sense that it's unremarkable. There's a single chip here, and embedded in this single chip is the firmware in a way very similar to the CC3100. There's a crystal and a level converter buffer. Otherwise, we have an antenna and a microcontroller. Okay? So let me demonstrate the software to you. And again, this is the starter project for the ESP8266. You'll want to get the version that's in zip file posted on Canvas, and not the one that you got last summer when you downloaded the whole thing. All right, so let me build it and debug it. See how far we get. Okay. Just like the other application, it spools out a lot of stuff to the serial port. So let's open up a serial port. Open. You'll probably use PuTTY, but I use this Texas display program that we wrote. It's a fairly lightweight implementation, and again, the advantage of the CC3100 is there's about 12, 13, 20 different applications you can start with. So far in this world, we have one, and that's fetching data off of the weather server or pushing data onto the 445L server. All right, step over. Disable interrupts here. This is written in Valvano-ware style. If that's good or bad, that's just the way it is. The LEDs are the lights and switches on the launch pad. Not much interesting there. This output init is my version of creating printf to work. So basically it implements putchar, and after you implement putchar, in this case sending it out to the serial port, printf will run on this system. All right, so step over. Okay. Tab. Yeah. See, so why isn't the whole character there? Why isn't the whole string there? Does anybody remember? 319K question. Did you see I output a whole bunch of stuff, right? System starting. And why don't I see it all? Because of the hardware FIFO in the UART. So it's sent out. It's got 16 characters in the hardware FIFO. The characters will eventually come out. The processor is halted because I did a step over. All right. I'm going to step into this one because it's interesting. Move this over here. Step in. Okay, so you remember the steps that we had last time with the CC3100. We're going to do it, but the syntax will be completely different. Okay. Do you remember the CC3100 used what protocol to communicate with the processor to the CC3100? It used SPI. Okay. This one is going to use UART. Okay. This one is going to use UART1. And the connections are up in the comments. Okay, step over. So there I'm implementing UART1. It turns out the interrupts are going to be enabled for receive, but it'll use busy wait for transmit. Okay? So it's going to use blocking busy wait on transmit, and it'll use interrupts on receiving. And there's a couple of things that are interesting on the received data. The first is shown here in this buffer here. This machine will give you the last 1,000 characters that it received. Okay? So in this buffer here, you're going to see a lot of activity, and it doesn't ever empty. All it does is scroll around and lets you see the last 1,000 characters that have been transmitted. All right. Step over, searching. And what it will do in order to check for errors, it uses a search mechanism to look for certain strings. All right, so keep going. All right, till we get to something interesting. Did I reset? I didn't reset yet. No, okay, reset. All right, let's go into reset. All right, the way this protocol works is what's called a AT protocol, and to implement a initialization, we're going to first give it a hardware reset. It turns out port B, bit 5, is tied to the reset pin, and I'm going to drive it low for 10 milliseconds, and then I'm going to send the at.rst command. Okay? Interesting is, look at the junk that came out of it came from it. Do you see that? Does anybody know what that means? That means the baud rate's wrong. Okay, and it turns out this has got a really awesome thing. If you were building this and had to communicate across serial, you could specify the baud rate, or what's the other option you could do? If you have two devices manufactured at different times by different people and you want to connect it up with UART, and you're the smart guy, what would you do? You and I are going to talk on the internet, or we're going to talk across UART. You and I are going to talk across UART. Okay? You're smarter than I am. Okay? I'm going to pick a baud rate, but I'm not going to tell you what it is. And I want you to talk to me. What would you do? What would you do? All right. Well, this is fine. Let's. What would you do? Come on. I just sent you this. What would you do? I just sent that to you. Not interrupts. I just sent you that pattern, and now I want to talk to you. Does anybody speak more than one language? Yeah. What happens if I say hola?
I know you speak in Spanish.
Yeah, she's going to speak back in Spanish. Okay? Right? I don't know very many other ways to say hi. That's the only one. Ciao. I guess ciao's tough, right? Because ciao's hello in Portuguese and Italian, right? So you got to be careful sometimes. But what am I? What's embedded in here? The baud rate's in here. I just sent this to you. What can you do? Figure out the baud rate. How? Right? Measure it. Okay, it's going to be on the final exam. Once we get past lab 10, I'm going to show you how to measure pulses. Okay, but this guy measures the pulse. All right, let's go back to mine. All right. Yeah, step over, step over, step over, step over. And eventually, oops, I did a step out. Oh, step out's fine. Step out is fine. You can see that it eventually got it. Okay? Actually, it's running. All right, it's going real fast now. And you notice a bunch of stuff happened. Let's go over to the UART tab. Okay. Some interesting things happened. These are all the access points in the room, by the way. Look at them all. It does have an interesting feature, and that is it showed you all the access points. But the other thing that happened, I don't know if you noticed it, but it tried to get onto the access point 5 or 6 times, trying to talk to Young Chen's laptop, okay, over and over again, and eventually found it. So looking at this window, these are all very, very interesting. Let me jump right to the end, and I don't see it yet. Oh, it's now it's stopped. I see. Now I got to go. Okay. Oh, I did a step out. I see. All right, so that connected me up. This one's interesting. This will be something for you to. This will be something for you to tell us when it doesn't work. And that is, there's the firmware number. This is version 18. Okay, this is firmware version 18. So as you buy one from China, this will let you know whether yours is newer or older than mine. All right. I've tried two, and they were both version 18, so that's all I know. All right. Now they step over this time. Step over. Status is interesting. Status will tell you how it works. Let's jump in and look at the connection. Do you remember the fundamental action associated with connecting up to a web server is a socket? Okay, and last time when we communicated, we called the function twice. We created a socket and then we opened the socket. But to open the socket, you remember what I had to give it? I had to give it two pieces of information. I had to give it the IP address. What else did I have to give the socket? The port number. I gave it the IP address and the port number. How did I get the IP address? What thing on the internet will take the openweathermap.org and give me its IP address?
DNS.
The DNS, the domain name system. Okay, this is they're really playing kindergarten with me. All I'm going to send it in is the openweathermap.org, and it's going to create a socket, go into the domain name system, and then open that socket for connection. And that's this command right here. Okay, it's going to open the type as TCP. It's going to open up the port. There's the port number. Okay, and okay, let's send it. Okay, send command is just like print string. Okay, it's just like out string. Just sends that string out to the device. It's a little bit of a waiting game. That's 8 seconds. Turns out it's gonna return probably faster than that. Let's step over. Step over. Step over. Step over. Okay. Searching. Found it. It's trying to connect up to the internet. Remember we learned last time? We learned last time that you got to be patient. You can see it's getting a DNS fail. Look at that. I can see that. I can see that it's trying to attach in and getting a DNS fail. All right. You can see it doing it over and over again. Fail. Let me go ahead and stop it, restart the whole thing. I'm going to power cycle it. You're looking at the buffer. You can watch what it's doing. You can see now that it's trying 1, 2, 3 times to log on to Yung Chen's access point. Fail. Good. Busy. Yeah, the internet's fun. Busy. Oh, we're on. There we go. Connected. It just sent out that packet. The green light's on, so I got the weather. I can see it over here in this memory 2. There we go. There's the weather. I just got it. So in summary, we got to take patience. You need to be able to observe things. And in the context of Lab 4, there are 2 ways to observe. First is you can look at buffers here in character mode. The second, you can look at the output stream. Okay? So let me remind you the steps. You have to connect up to the access point. You need the SSID and the password. You open up a socket. In the CC3100, you use the domain name service to convert over to the you use the domain name service to convert over to the IP address to the But in this context, all I'm going to do is send it openweathermap.org and make a connection. Okay? And at that point, to send a TCP packet, that was just another one of these things, and I'm just going to send. That's the exact same message we sent on Friday using the CC3100, and then it will wait for the response, show you the response, output the response, and then it will close the connection.